all of you that are out there in some way are helping us with Special Hauling Vehicle Contract 9. And as you're aware, a big part of this is the more advanced timber bridge inspection component of things. But I'll let Kyle and John take it from here. Thank you.
So what we did as kind of a courtesy after we started and inspected a couple bridges was we kind of laid out our process and shared that with Dave and Moises just to make sure that our approach was something that was acceptable and kind of moving forward before we, did the other 50 bridges on our list. But so we kind of parsed out that memo into just a short presentation. Like Dave said, this is not the end all, but just kind of what we found that's working for us and they seem to be on board with. So just as a kind of a share to show all what we're doing and kind of keep the conversation open and loose, I guess. So we kind of broke it down into the few steps as once we get out to the bridge and we get under the bridge and once we get to doing the piling and any of the substructure pieces, we'll go through and we'll kind of dimension and mark each pile as our first step. Then we run through, take our stress wave timer readings and any other moisture readings throughout the pile just to kind of give us our first level of data. And then step 3, kind of moving on to the drilling piece, and then step 4, looking at the pile caps. So moving through, that's kind of step 1 is what we do is we'll come out and we like to label each pile at about every foot. We're labeling them also by the substructure and the pile number, but the designation we try to use is kind of gleam over the structure inventory report or any other documentation that a county might have or the owner and follow their naming convention. And when they don't have one or we can't see that they're using any, then we just kind of use standard convention from ascending order going south to north or west to east as you typically would based on I believe the VSIPM states that. As I mentioned, we'll graduate each pile from bottom of cap every foot so that when we're coming back through, it's a simpler way to record on our spreadsheet that we use in the field to apply any readings, values, drill locations that we're finding. And just kind of helps us kind of traverse through the bridge. And we've been writing a lot of things, as Collins had suggested on the kickoff of this project, was using lumber crayons has worked really well. So I appreciate that tip. And then that we'll just write spacing, and then typically the other team member comes behind and records these things on our field notes and sketches that we're using. I'll kind of show you what we're generating as a deliverable at the end of this. So once we've gone through and kind of dimensioned all the subs and gotten them all labeled, then we'll run through and we'll start taking our stress wave and moisture readings. So this kind of being our first line of analysis out there in the field to know where we want to drill and to what extent we feel we should be drilling. So our minimum is that we're going to take 2 of the stress wave readings at every foot. So we do take stress wave readings every single foot, having someone recording those values as we go. What we did is, I'm sure you've all seen it in the timber advanced timber bridge inspection manual. They've got a chart that really kind of gives you a guide, I should say, right? Because every pile is unique to itself. But we've taken this guide, as they've called out, for sound to minor, moderate to severe decay. And we've formatted our spreadsheet so that when we're punching this in the field, it'll flag it for us, turn at these colors so that we know, hey, we're going to want to come back and make sure we drill this location because it's indicating there could be moderate decay. Sometimes we will still drill closer to the connections, as you all may be aware of. It's, we're not always finding that the loss is worse at the base near waterline or at the top, but a lot of times we're finding some really poor areas right at these connection points. So as far as the stress wave goes, we will go through after we've graduated, and you'll kind of see here, we'll end up circling them whenever we get these readings of 400 or above, so that when we come back through with the drill, we can quickly identify where we for sure want to drill, just to do that non-destructive testing. Yeah, so I think that kind of covers everything I laid out on the sheet. And a lot of this is just a little more text because this is essentially what we had shared with Dave and Moises when we first proposed our method.
Say, Kyle,
Yeah.
quick question, like in this photo, are you guys in like waders or what do you, when you're going out and marking this, I'm assuming, I'm seeing some water, right?
Yeah, I mean,
And
we'll get out and determine if we need hip or chest waders, and then
sure,
you know, sometimes you get lucky, sometimes you don't, and you can work off of a pretty gradual slope off of land, and so we kind of just whatever's needed, and we always bring our boat to most of these inspections unless we know for sure we don't need it, but we like to just be prepared and be able to access if it's here piling that's going to need us to float out there and get a better handle of it if we can't do it by chest waders.
okay. And are you doing any little probing below the water line since you're right there?
Yeah, we'll do some sounding below water line.
Okay,
Obviously, we can't get the drill down there and we can't start
sure.
sticking these leads of the stress wave timer down there or moisture meters. So we'll
Sure.
just, we'll do our best to see what we can see if the water levels allow us to.
Okay. Sounds good. Thanks.
Mm-hmm.
Hey Cal, this is Mark Parker. You might address this in the upcoming, but have you determined like what the time difference is if you don't do stress wave and you just drill every foot at 90 degrees? Because stress wave is you're going to get indications of potential and then the drilling will confirm it. But I was just curious if you guys have recognized the significant time savings by using the stress wave.
The stress wave goes fairly quick with a team of two and just kind of running through it. But no, we haven't looked at what it would take to drill every single foot versus doing the stress wave. But I do agree that, it can give you varying results because we will find areas that that are giving us a higher reading, but drill okay. So it can be a bit deceiving, I believe, but we've taken that approach to, when drilling every foot at 90 is when you've got 12 feet of exposed pile it tends to add up on us. So that's kind of why we took the approach to rely on the stress wave to help us. But then also at a minimum, we're still drilling the pile at 2 to 3 foot increments when it's all said and done.
Okay, cool. Thank you.
Yeah. So then kind of in that same breath of the stress wave, we'll take our moisture readings. And that one we typically will take at the top, middle, and bottom of the pile, bottom being closest to water line or existing grade, whatever is there. And we take the lumber crayon and mark that out. You can't really see it well here, but it's the red color we're using out there. And so then one person can go ahead and do that while the other person might be labeling. So we're trying to, to Mark's point, find some efficiencies out there to be able to be recording things, writing them directly on, and then having the other team member to collecting the data as the other one's continuing on with more documenting. So I guess any questions on kind of the first couple steps we've presented? Okay. So then the next is we'll come back around after we've collected that data, and then we'll determine our drill locations. We've started with about a minimum of 3 drill locations, but like I said, it kind of averages out to be about every 2 to 3 feet, because once we've got a pure pile that might be 9-10 feet exposed, we're going to make sure that we're at the top, bottom, and then starting to hit some of those cross bracing connection locations. But as you saw on that table prior, based on the stress wave timer, anything greater than that 400 microseconds, we're flagging, and we're just making sure we drill at that location. And typically, if we drill a location, let's say we drilled at this 1 foot location, and we found it to be in poor condition, then we're gonna drill it you know, this was east-west direction as we labeled on the pile. We'll drill it through at 90 parallel to the back wall, and then we'll drill it in 2 other locations. We'll kind of turn 45 degrees and get a cross section of that location. And if it's really bad, then we'll actually, you know, we'll jump down to the next foot or half a foot and take some more drills to make sure we're catching the worst of it above and below. And so we'll label these drill locations after we drill it. We'll circle it. We'll give it the number that our drill is telling us it is, and we'll give it the directions. So then in our spreadsheet that we're recording in the field, that we have all that data and can really just keep everything straight. And it's kind of helped us organize the data and be able to really pinpoint and locate it at the end. So yeah, I guess I've kind of mentioned the drill direction and just making sure we're giving it the cardinal directions of which way we're going, and then we're recording all of this information in our spreadsheet in the field, and making sure that we kind of get a good cross-sectional area of what we're finding there. And then the last step is we've taken the approach to really just hammer sound and visually assess the caps and try to find the worst areas, you know, based on moisture retention in there, and you know, and just visual condition. And so when we do that, then if we find areas that we find that we want to drill, we'll go. In this case, we ended up drilling out in the middle between these piling that were steel pile on this bridge, and we ended up coming through the face at 90, and then, or at 0 degrees, I should say. And what we've been doing is setting that drill at as long as we can get it to go, which I believe the hypotenuse up at 45 degrees, like about 17 inches, which the drill only goes 16. So, but we'll get that one at 45, and then we'll have to actually turn the wood inspector off, because we've been leaving that on, but then turn it off to go vertical. And so if you all don't know how to do that, I had to work with Josh at State Aid there to help me on that, but it's really just when you're holding the drill, hold the red button, and then you can find the toggle to turn that off so that it allows you to drill past that 60-degree tilt limit that you get. And so then that way we get a fairly accurate section of what's happening in the pile, and oftentimes if we can't get at under or in other directions, we'll try to just drill down the whole face at 2 or 3 increments to really find what's going on, and then discern that from the drill results and figure out what kind of section we got remaining. So I guess any questions on comments or anything maybe anybody else is doing that they feel is helpful to share with the group here on just kind of the drilling process and labeling and identifying?
Hey, this is Mark again. Have you guys found, or anybody, several or often instances where you're drilling and it follows a check and kind of comes through at a angle different than 180 from where you're entering? And how often is that occurring?
Yeah, I would say that happens, and I don't think it's the majority of them, obviously, and we are watching that drill bit come out on the other end to make sure that we're not just, you know, sometimes you'll go in at, you know, hoping it comes out directly the other way, but it might turn 30 degrees the other direction. Then we'll identify that and make a note in our spreadsheet and say, you know, drill wandered, and then we'll re-drill it above and below. But it does happen. I would say maybe 10% or less, maybe 5 to 10% of the time you'll see it wander a bit, but maybe 5% is to the point of where you wouldn't want to rely on that result, is what I would say. Have you come into that a lot, Mark?
You know, probably similar, not necessarily a lot, but we've definitely seen it. And sometimes when you're doing a cap or something where you're not seeing it come out the other end, we've just been, if we get a result that's, you know, suspect, then we'll try to re-angle it a little bit or move locations a little bit and determine if it's a check. And a lot of times if there's like the latter end or the latter half of the scan or of the reading is bad and you don't hit that back wall, you know, say you're looking for an interior that's decay, if you don't get something at the back end, then that is a good indicator that it's not coming out or that it's following a check rather than going through the center. So it's more suspect when we can't see the side that it's exiting out on, right?
Right. Yeah, and good point when you're going in, when you're going into like the face of a pile and going towards the abutment back wall, right? Just knowing when you're going into a back wall potentially, or you're kind of hitting other things that wood inspector can be deceiving at times. So then I guess we just threw in a couple of examples of what we're trying to utilize the sketches that are provided. We use these in the field and kind of clean them up in the office. So here's what we're doing with the pile data and the timber sketch. We give them we label the pile, give them an elevation, we get the cardinal directions as to what we're displaying in our sketch. And I think since then since I produced this, we've been actually showing, you know, where does the edge of slab or edge of beam and where does that relay with respect to the cap. And so we'll have the overhanging distance here as well, if any, but just really trying to show the exposed pile and the different spacings so that if we find what we have to load rate, we can do it with the proper exposed pile spacing and whatever else we need to know. And so just a way to show the county and the owner, whoever it be, what and where we drilled so that they can identify, and we can also easily have a better reporting and showing of what we did and where all the condition of everything is. And we will end up summarizing the condition state for them in the end. And then this is kind of just a snapshot of the spreadsheet we use in the field. There's some things off the page that are referencing, but really we label what substructure we're at, what our element is, our pile number, and we're at Pier 1, Pile 7 in this case, and then our distance from our bottom of cap that we labeled in the field. And then our stress wave readings. And then, like I said, that we've just kind of formatted to flag those so that the person recording can just holler back or circle themselves which ones we want to make sure we get back to. Recording moisture, drill number, directions, you know, it's pretty self-explanatory. And then our section loss was provided based off of some off-sheet data that we pull from our drill results. And then we're assigning condition states, and these are either overridden based on observed condition, or they're a computation of section loss based on the BSIPM guidelines. So that's kind of the long and short of what we're doing. So I think we can leave it open to questions and comments, and yeah, thanks everybody.
Quick question again from Mark Parker. Have you guys, I guess, and this is maybe more of a global question, have you guys been seeing more or less than expected? You know, you do your visual and then we're drilling. I guess speaking from Collins, we've not encountered a ton of interior decay that we were maybe expecting to see based on visual. So we were a little bit, going into this, maybe thinking it would be the opposite. Are other firms seeing that, or maybe it's just our subsample?
Yeah, I think, you know, what I was surprised at from our standpoint and what we're seeing in the field is that I'm a bit surprised at times of where we'd hammer sound and think it's, you know, it's okay and not in poor condition, but we're actually finding that there's more internal loss than we would have anticipated, as opposed to just hammer sounding the bridge in the exterior visual condition. And a lot of that for us is showing up at, you know, these either a former bolted connection from these cross bracings or at these bolted connections where it's just this penetration point that didn't get treated. So we're finding a lot more poor condition at those locations on pier pile per se. But that's I guess what I've noticed in the dozen or so bridges that we've done.
That doesn't, what I'm hearing from you guys, I guess doesn't really surprise me based on my dealings with the Forest Service. Exactly kind of what you're saying, you sound it and it sounds like it could be bad, but it's not, and or vice versa, where it sounds crappy and it isn't. And so this is kind of reflecting their experience too, hearing what you guys are saying. And Mark, kind of getting back to your question, I know Ron was out in Martin County and there was at least quite a few bridges that he looked at that were in really tough shape. One, I think they had to close the bridge, so it could be part of your subset, I guess. But in that case, it was pretty bad shape.
You guys have
Ron only uses a hammer, so he's got they got the equipment, but that's what he found. What were you gonna say, Mark?
Oh, sorry, this is Jameson.
Or Jameson, yeah.
Yeah. Have you guys encountered any access issues? And maybe I was a little late, so maybe you covered that, but
I think we talked about that.
We haven't had a lot of access issues. It's just, what we've found is it can really lengthen our time in a bridge as to the most that we've done is, we've been able to handle the bridges we've been at using either hip or chest waders. And then we have a smaller-ish extension ladder that can be cumbersome getting up out in the pile and up on the caps when you're looking at piers, but based on how rocky the bottom is, and that's been I'd say one of our bigger challenges is kind of maneuvering our ladder to get it at these pier pile and caps, but it just that does add a little time, just kind of monkeying around, moving around, making sure you're not damaging equipment and whatnot, and making sure you're getting around at everything safely. So
okay, good question, Jameson. I was curious on that too. So because Jameson talked a little bit, before I forget, SRF has been hired by us to update the Advanced Timber Bridge Inspection Manual, if you will, done by the Forest Service. And I know they've been trying to pick away at it. I think we've got an outline and stuff, but that's to try to update it for the new SNBI and whatnot, and some of the things that we changed in our condition states. But anything you want to add, Rick or Jameson, to that?
no, I think it's just going to capture a lot of probably what you're doing in here,
Sure.
and what we'll end up doing with the rest of the bridges on this contract.
Jameson, you asked about timing and access. It's kind of interesting, but we've kind of found that it's taking us about 2.5 hours per substructure. And it's been pretty consistent at all the timber subs that we've been at, that's what it takes to do all of our kind of the steps we've explained today. I don't know if maybe that comes back to Mark, what you were talking about as far as how long it takes to use the stress wave versus drilling every foot. But just thinking about your comment there, I guess that's kind of roughly what we're finding. So
like a bridge like you have here, I mean, is that a 10-hour inspection for this one bridge?
Yeah, we spent a little over a day at this one. We had to go back to it the following day, I believe. And so, but this one's a little bigger. It's skewed, a big skew, and it was a 3-span structure. So
is that consistent with your estimate, your fee estimate, or not? Or is it kind of depend on the bridge, it washes out a little?
It's fairly consistent. It goes a little more efficient when you've got a bridge that has about 5 or 6 feet exposed and you don't have to wear any waders and you're just working on land on an abutment, you know, those are,
Sure.
those you're doing in a little under 2. So I think we're
Okay.
close, if not a little better, a little more time spent at some of these subs, just because
Is that 2 man hours or 2 hours?
2 hours of 2 people at a sub is about average of what we're doing. So
like this bridge would take you over 20 hours to inspect, man hours.
yeah, about that, about 18 to 20 years, say.
And that was consistent with your estimate.
Yeah, it was pretty close to what we assumed at each substructure, around 2 hours.
So I have a question. How much time are you spending on, like, I always print out the routine inspection reports previously and just kind of make sure everything's jiving, but how much time are you going through with inspecting the rest of the bridge?
Well, we still have to load rate the superstructure, so we still do our typical assessment of the super and any of the other surrounding elements that we have our own checklist that we do for each structure. And so we're still spending anywhere from probably 30 minutes to an hour based on what type or how big the super is. So we typically do that prior to going down and underneath the bridge, and then spending the rest of our time analyzing the subs. So.
All right, good questions. Let's see here. Any questions on equipment, or you guys having any issues? I know we've got Rodney, Carter, and then I heard Josh's name. They're the 2 gurus from our little group here, State Aid Bridge, that have been out there trying to help here and there. But any feedback on that component of the discussion here?
All good things, I'd say, Dave. Josh has been really helpful whenever I've got questions, and Rodney is also always there to help us either get equipment or retrieve new drill bits as we need them. So
yeah,
it's gone well.
Good.
This is Mark with Collins. So we have not had to use our underwater unit recently, but we will have to use it. And I guess just letting everyone know, if there is a situation that you encounter where we need to drill underwater, there is an option to do that, and we can work through, whatever avenues to get that done. But we will plan on having it for a good chunk of time here, either late this year or early next year.
At this point, could that be something you guys as inspectors and load raters make note of it, maybe in your evaluation of the bridge, that, yeah, this might be a good candidate for some underwater inspection work?
Mm-hmm.
And then we could kind of develop a list, something like that, Mark. As we complete more bridge inspections. Thoughts out there?
Yeah, I think typically when we go to a bridge, we'll always keep that in mind. Check the SIR if there is, if it's on the list, and then if we feel that, by reading the notes and when the last time a structure had been seen, whether it's a timber sub or something else, any other type of structure, we're usually reviewing that and suggesting it on our final reporting to you all and the owner.
That sounds good. Kyle, do you guys, on some of these, are they noted to have previous underwater inspections?
Yeah, you can see right on the structure inventory when it's due or when it was last done, I believe. And then often there's notes in there. I mean, we don't, now that we have SIMS access, right, we'll have the report to the bridges, and we can go back years and grab those reports that Collins would have done. So that's helpful, because then it gives you the flow line and sketches and things. That's helpful.
Okay, good. Yeah, I think that's maybe a tip here, is to tap into that if you haven't, because there may be some really good notes in there that were missed by the program administrator or maybe the team leaders of that agency. So recommend
Yeah,
that for sure.
and once we had our list final and once we got the Sims access, one of our first steps was we ran through and grabbed all those Sims reports and reviewed them for, I guess to Jameson's point, what kind of access we think we'd need. So if there was some good photos, knowing that time of year and flows are dependent, obviously, but if we felt we'd for sure need a boat or maybe we can forego the boat on a certain trip, then that just helps us plan.
Yeah. Right.
This is Jim from TKDA. Is there what anyone know what the seasonal limitations are going to be for the resistance drills? Is Rodney going to call those back based on calendar day or temperatures or?
Good question, Jim. I don't think unless there's, we need them back, I think we'll just let you guys hang on to them and use your good judgment.
I thought Rodney was going to be sending them off to have them calibrated over the winter.
To get ready for the next inspection season. Yeah, that could be. Yeah, I see. So we definitely, want you guys using that as long as you can go until things start to get cold. I think that's the big concern that we're using them. If there's water in there and things like that trapped in the members. Nothing that I'm aware of that there was some kind of set date to get them back, but I will get something out to you. Would that help?
I think that
to the
would
groups.
just help us planning. Yeah. Thank you.
I have maybe a question for Mark Parker. Since you all own and kind of manage your fleet of drills, how often do you have to disassemble that chuck and get in that chamber? Do you find that you get a lot of debris within the drill itself?
Yeah, we do it probably after every other bridge.
Okay.
There's some pretty good instructions from IML on how to do it, but especially if they're creosote, which maybe a lot of these aren't. We do a lot of railroad bridges that have heavy creosote, and it gets real gunked up, and you can almost see at the end and from the bits how much gunk you're getting in there. But we've made a fairly regular habit of trying to do it more often than not.
Okay.
And I guess one other thing, if we are going later into the season with these units, I do recommend taking them inside. I mean, I don't think any of us really leave our equipment out in the vehicles, but with temperatures dipping low at night, it's recommended to not leave them out in sub-freezing temperatures. So just make sure you're taking them out of your trucks and bringing them wherever.
Good advice.
Thanks, Mark.
Was this presentation something that you'd be okay if we send it off to the team here of SHV contractors?
Yeah, I'll just make a PDF and send it to you, Dave, and
yeah, Moises, and then you can copy me. That's fine. We again, I state this all the time. We really enjoy working with you guys on this meeting and appreciate LHB's extended time to put this together to share kind of their lessons learned and how they're approaching things. And if you guys want to get together again, like if SRF is finding things, or I know Mark has done this as well for us. So it's all kind of a team approach here to be working kind of on the same page and approaching things and learning from each other, because this is kind of new territory for several of us. And of course, in-depth timber substructure inspection is something that is long overdue, but it is kind of a little bit newer thing here, and drilling and documenting and trying to do it the right way to get a good baseline. So again, appreciate all the work, and just stay in touch if you have questions with your schedules, your budget, that kind of thing, and try to work with you guys on that to accommodate the heavy load you have with other work items. So that's all I got. If there's any other questions, I think we can move on with our day here.
Sounds good to me. Thanks, Dave.
Appreciate it.
Thanks, Kyle. Thanks, Dave. See you,
Thanks,
everybody.
Kyle.
Bye,
Thank you.
everybody.
Bye.
Yeah, thank you everyone for
Thanks, everyone.
Thank you. Real good.
Yep, thanks.
Bye-bye.
Thank you.
Thanks, Kyle.